Hey, welcome mathematicians to today's video. We'll be looking at time series, and the skill we're looking at is mean smoothing for odd numbers. So let's jump straight into it. Okay, our scenario is the table below shows the number of letters in total for the last 10 text messages sent by an individual. So we look at this table, we'll see we have text number 1 has 88 letters, text number 2 is 79, all the way through to text number 10 has 66. And our task for this particular video is to perform a 3-point moving average smooth, and task number 2 is perform a 5-point moving average smooth. Let's have a look at how we do a 3-point moving average smooth first of all. So even in the title here we have the words average and 3-point. So that gives us a bit of a clue. Let's have a look. What we do first of all is we find the average of the first 3 entries. So we're taking the number of letters for message 1, 2, and 3, adding them together, dividing by 3 to work out the average. So we're using 3 bits of data, hence the name 3-point, and we're using the average value. So that's why it's called an average smooth. And that value of 83.3 is centered against the middle message number. So I've got message number 1, 2, and 3. So the middle point of that is 2. So that's our first point of our 3-point moving average smooth. There's nothing in this cell above it. Okay, we would need to have some value before message 1, 1, 2, 3 to find an average for that particular cell. We can't, so an average of the first 3 is centered against message number 2, and there's no data for message number 1 in our 3-point moving average smooth. Our next data point, we simply move down 1 point in our set of 3. So we were, for our first smooth value, taking the first 3 values from the letters, we now take the next 3. And we work out the average of those 3 numbers. So we have 79 plus 83 plus 80, all divided by 3 to work out the average, and that returns a value of 80.7. And that is centered against message 2, 3, and 4. Right in the middle is message 3. We continue that process on. The average of the next 3 is 78.7, and it's centered against message number 4, the middle of the 3, 4, and 5. Move down, the next average is 74.7, and it's centered against message number 5. Next average is 75.3, centered against number 6, and so forth, till we get to our last final 3 set of letters, and we have a 3-point moving average of 68.3, centered against message number 9. So when we do a 3-point moving average smooth, we lose 1 bit of data at the top. That is, message 1 has no average data against it, and we lose 1 bit of data at the bottom. Message 10 has no 3-point moving average data against it as well. So this is the graph using our TI-Nspire, and we see our original data, letters in blue, has a fair bit of variation. It jumps up and down. There's fluctuations in that data considerably. Then, once we've used a 3-point moving average smooth, we end up with this orange set of data. So there still is variation, as in low values pull the 3-point moving average down, and high values pull the 3-point moving average up. But in general, that has reduced the amount of variation or fluctuation. It has smoothed out our data. And of course, the cost of smoothing that data for a 3-point moving average is that we lose data for text number 1, the first set of data, and we lose data for text number 10, the last set of data, as we've seen with the line here in the table and the line here in the table. Once we perform that smooth, we can come up with an equation for that particular smooth data that allows us to make accurate predictions. So in this case, we end up with the following 3-point moving average smoothed equation. Linear regression says the number of letters is equal to 86.15, take away 1.84 times the text number. So that is our smoothed linear regression. Let's have a look how that's done on our TI-Nspire. Okay, let's make ourselves a new list and spreadsheets. Let's use some easily recognizable headings. Let's enter our data in. Okay, we've checked our data. So we have our first column A, the messages, and our second column B, the letters. Let's now do a 3-point moving average. Okay, so I've given it the heading of 3-point moving average. Can't use numbers in heading titles, so I'm using the word 3PMA. We know that there's nothing returned in the first cell in column C, so let's go down. Let's work out the mean value for the first 3 cells in column B. All right, I've got a function for mean, so I use the equal sign first, then I type in mean. Now I want to reference the cells. I want cell B1 to B3. B1, now I use this little symbol, colon, B3. Brackets are closed. There we go. The average of the first three numbers is 83.33. Now you notice also it puts out a little line there, which is really important later on when we're graphing data. Okay, so that automatically happens. Let's move on. Now that cell, instead of typing out every time, what I wish to do is repeat that calculation for the next three, then the next three, then the next three. And there's a quick way of doing this. I highlight the cell and I press on the center of my stylus for about a second, and then I just drag that down, and that will just repeat the same function down to cell 9. Okay, let's see what that's done. So I started with working out the average, or the mean, of B1 to B3. That's these three cells. The next one, if we watch this reference down the bottom, instead of B1 to B3, it's B2 to B4, B3 to B5. So it's moving down every time. 4 to 6, 5 to 7, 6 to 8, 7 to 9, and finally it goes 8 to 10. Now at this point, we've got this cell with nothing in it. This creates problems later on if I want to graph. So it's wise at this point to, again, down the bottom under the enter, use this key. Okay, now that represents no data, like this one does at the top, and that's really good for graphing later on. So let's have a look at this. We've got our message number, we've got our letters, and we've got the 3-point moving average. Let's now produce a graph. So first of all, the most obvious would be letters, messages. So there's our original data. And I can go to menu, properties, and I can connect the data points. That displays a traditional join graph. Okay, a lot of variations in that data. Big spike here at message number 7, it's quite large. I can also go to menu, plot properties, and add Y variable. Now I'm going to put in my 3-point moving average. So I'm now going to have both sets of data plotted together. So the blue one's with the original letters, and the orange one is the 3-point moving average. So that has removed the fluctuation or variation away from our original blue plot. We don't have the extreme ups and extreme downs. It's more of a straight line. So it has in fact smoothed out our data. It does that by design. However, you'll notice that point 1 lost data and point 10 lost data. So that smoothing comes at the cost of losing data points in my data set. Finally, I'll do another plot. This time I'll look at my 3-point moving average against my message. I can go to menu, analyze, regression line, and the traditional show linear regression of a plus bx. If I do that, I now have a nice straight line that allows me to predict that y, the 3-point moving average number of letters, is equal to 86 take away 1.8 times the message number. And that is rounded to only 2 significant figures. Now let's have a look at our 5-point moving average smooth. Again, the name suggests very clearly what we're doing. This time we're going to take 5 points and work out the average. So the first 5 points, we have message 1, 88 letters. Message 2, 79, 83 for message 3, 80 for message 4, 73 for message 5. We add them together, and always to find the average, we divide by the number of entries. So divided by 5 gives us a value of 80.6. And so we're looking at 1, 2, 3, 4, 5 bits of data. And the average is centered against the middle one, which is message number 3. Now we move down 1, hence the name a moving average. Move down 1 point. So here's our 5 numbers. Dividing by 5 returns an average of 77.2. And that, of course, is centered against message number 4. We move down 1 more, and we get an average of 77.8, which is centered against message number 5. We move down 1. The next 5 bits of data from message 4 to 8, that has a 5-point moving average of 74.8, and that's centered against message number 6. The next value is 73.0 as our 5-point moving average, and it's centered against message number 7. And our last 5-point moving average return is 71.6, and that's centered against message number 8. Now I can't go below that because I don't have 5 data points to actually do a 5-point moving average. Likewise, at the top, I can't go above message 1 to produce a 5-point moving average centered against message 1 or message 2. So that's the end of the data. Here's our graph again. Our original letters and texts are displayed in blue, a large range of variation and fluctuation. And our new 5-point moving average smooth is displayed in orange. And whilst there's still some variation, that looks a lot more linear, and we've removed the fluctuation from point to point. Again, we can find a regression line for that 5-point moving average smooth, and that can be used to make predictions about data. So the linear regression for a 5-point moving average for this data says the number of letters is equal to 85.36, take away 1.73, multiplied by the text number. Let's now look at how we do this using the TI-Nspire. So with our title, first entry of our 5-point moving average for our message and letters will be in the third cell. So it's equal to mean, open brackets, and I'll want to again go from B1 to B5 this time. B1, then my colon, to B5. We're going to work out the mean value for the first 5 elements in column B. There we go, and again, it returns a nice little dash, which is important with our graphing later on. Without these dashes, we have issues with a mismatch of letters against numbers. We need to have those in there. So I'm going to click on that, go over to my stylus, hold that down for a good second, and then I can take that down, copy it down. I only want to go to number 8. Very good. So there's our data. That is a 5-point moving average. So the first one was the mean of B1 to B5. So this is column B, 1 to 5. We go down to the next one, it's 2 to 6, 3 to 7, 4 to 8. So we're taking 5 at a time, continually moving down, 5 to 9, 6 to 10. Okay, we can't do a 5-point moving average for the last 2 bits of data. What we can do is fill them in using this particular symbol. And it just works for graphing. Done. Okay, let's now graph. So first of all, let's have a look at our letters against our messages. I want to go menu, plot properties, and I want to add a Y variable. So the second one will be our 5-point moving average. There we go. And if I wanted to, menu, plot properties, connect data plots. That's what it looks like in most of our textbooks and exams. So our original variation of our number of letters, it's going all over the place. And this is our 5-point moving average smooth. See again, the variation, the fluctuations have been removed even more. It's working out the average for every 5 points. Nice and smooth, does a great job. But you can notice again, it comes at a cost. We're losing data for text 1 and text 2 this time. And on the right hand side, we're losing data for text 9 and 10. The last 2 data points are also being removed when you do a 5-point moving average. You do certainly decrease the fluctuation and variation, but you lose data at the end to make predictions from. So finally, if I wanted to do a regression line for a 5-point moving average and our message, there's our 5-point moving average. I can menu, analyze, regression line, and we normally use the A plus BX. And there we have it. In this case, Y, the 5-point moving average for the letters, is equal to 85, take away 1.7 times the message number. And there we go. That's how we perform a 5-point moving average with the TI-Nspire calculator.
You've been watching a Juddy Productions video. If you've enjoyed and indeed learned something from this video, then please remember to like, share, comment, and subscribe. And as always, thanks for watching.